This question asks about the relationship between delta E and delta H, between change in energy and change in enthalpy. So it tells us that the enthalpy of a mixture of gaseous reactants increases by 329 kilojoules. So delta H is 329 kilojoules during this reaction. And then it says that they monitor the volume change and they determine that 65 kilojoules of work is done on the mixture during the reaction. So in this case, work is positive 65 because the work is done on the system, so W is positive 65. So we essentially have two equations. Those equations are delta E equals Q, heat, plus W, work. And we also have enthalpy, delta H, which is equal to Q at constant pressure. So these are the two equations that we have. So essentially, in a way, enthalpy is ignoring the work term. And if not very much work is done, delta H and delta E are very close. Generally speaking, reactions that do a lot of work or have a lot of work done on them involve gases being formed or gases being consumed, depending on the case. If a lot of gas is formed, the system tends to do work, so the W term is negative. If a lot of gas is consumed, then the system tends to have work done in it by the surroundings, so therefore the W term is positive. Anyway, to solve this, we can simply rearrange the equations. Delta H equals Q, so delta E equals delta H, just plugging in for Q, plus W. Plugging in, delta E equals, enthalpy is given, 329 kilojoules, and work is given, positive 65 kilojoules. When you add those two together to no decimal places, you get 394 kilojoules. So again, this is showing the relationship between enthalpy and energy, and they are not the exact same thing.